So this talks about a project called Let's Encrypt and how it will interact with Nginx to hopefully provide TLS for the entire web. So first, I'm Yan Zhu. I'm a security engineer at Yahoo and also a technology fellow at EFF. And this is...
I'm Peter Eckersley. I'm chief computer scientist at EFF.
Cool. Can you guys hear us okay over the background noise? Okay, sounds good. So Let's Encrypt is going to solve a bunch of problems. I'm going to talk about what those problems actually are. One is very obvious, that TLS is not ubiquitous, even in 2015. For instance, when I joined this Wi-Fi network, Nginx, a few minutes ago, I was able to go to Bing over plain HTTP and check whether there was a captive portal or not. Here's another example. In 2014, I was logging into Quora, and I noticed that they were sending my password over plain text by default, unencrypted, no HTTPS. Also, they were trying to run Flash over HTTP. And I said no, and I didn't use Quora for a few years after that. Basically, there's no excuse in 2014, right? So things have gotten better. And since then, Quora has implemented HTTPS by default, which is great. Many other sites have done that as well. But even in 2015, so you've heard of this little company called Google. And some people don't realize this, but some of their pages are still over HTTP. For instance, their default landing page for Google Ads. And you might say, okay, so that's not a problem, because Google Ads is just public information. It's just a picture and some information about ads, right? The problem is that a network attacker can inject a button that says sign in and trick a user into clicking it and maybe redirect them to a phishing site and then scoop their passwords anyway. So just having this one entry point not be over HTTPS is a real risk. The second problem is that setting up TLS is very tedious. How many people here have tried to set up HTTPS in the past? Quite a few, right? I actually was just doing it a few hours ago. And usually, if you're using a hosting provider like DreamHost, there's this crazy long process. You have to find some wiki page that tells you how to get SSL. You have to select your domain, generate a CSR, make sure you copy and paste the CSR into the right place and don't accidentally copy and paste your private key. And it all ends up being like a 14-step process. And when we did, so we've done some usability tests, and it takes even experienced developers, at least an hour to set up TLS. When I first made this presentation, I actually went around EFF and found people who had never set up TLS but were pretty experienced with computers, and took a video of them trying to do it for the first time, and made a little movie, which I'm going to show right now. Hopefully the sound is at max. Sorry. How do I click on this? I might have to exit and do this. Sorry, we are having network issues right now. Let's try.
There's a YouTube link in the corner of the page.
What's that?
There's a YouTube link in the corner of the page you might be able to paste.
Yeah. I think we're just not on the internet. Let's try. Okay, we are on the internet. Unless that was a cache load. Maybe we're not connecting to Google.
The long and the short of these experiments.
Okay, we'll just keep doing this.
If you want to, do you want to keep trying, or do you want to skip it?
Yeah, I think we're back on the internet now, which is... Sorry for this delay. Okay, here we go. Okay, back to playing this movie, hopefully. Oh, hello, Parker. What are you doing today?
Just gonna try to set up.
So the volume on this is pretty low.
on my website.
I'm gonna narrate a little bit. This
That
is my
sounds
friend
fun.
Parker.
Yeah,
Actually, you can
maybe.
fix it.
Can we film you for a DEF CON video?
That's okay, yes.
Great.
Okay. Okay. Wow, I didn't think that was going to be clickable. No kidding, it's 100% free. So, what do I? How do I do this? Free. Okay. Click the wizard. Start SSL control panel. Okay, I guess I'll open that in a new tab. Oh. Alright.
So what happened at this point was we tried to get Parker to get a free SSL certificate using startssl.com, and it was working okay until the site went down for maintenance, which actually happens a lot with this particular certificate authority. So Parker wasn't able to do this at all. And later I went to my friend Noah and said, Noah, can you also try this, and we'll film you and see if it's as painful of a process. But basically Noah got through to the point where, sorry. So I'll just skip over the rest of the video because it's pretty painful to watch. Basically no one that I talked to was able to set up SSL. And for Noah, the whole process took about 9 hours because he had to figure out like what email to get a domain, what email address the requests were being sent to, and so forth. Okay, so let's assume somehow we've managed to actually get ourselves an SSL certificate. Now we want to actually configure our server to use TLS. Then we run into the next problem, which is that TLS configuration is really confusing. How many people here have set up a server that used RC4 as one of the TLS algorithms, right? So this was pretty common. I remember in 2013 or 2014, it was still pretty common for people to use RC4. Like it was commonly believed that it was much faster than AES. So people would set it as a more highly preferred cipher than AES. And here's a blog post, I think from 2014, from Nick Sullivan, who gave an excellent talk earlier, that says, well, here in 2014, we've actually decided it's time to move on from RC4. Like there's been new attacks against it, and it's just simply not good enough. In fact, a few weeks ago, Google, Chrome, Mozilla Firefox, and Internet Explorer, which I guess is now Edge, announced that they were going to deprecate RC4 entirely by 2016. So now people should be scrambling to take RC4 out of their Cipher suites, right? Similarly, SHA-1 is now being deprecated, at least in Chrome and Firefox, because collision attacks are too affordable now. So we could make a small movie called the SHA-256 Redemption about someone who, wants to use SHA-1 and gets put in some sort of jail and then has to set up SHA-256. This is pretty silly. I didn't actually make this movie because my last one wasn't very good. And other attacks like logjam, right? Now you have to generate your own Diffie-Hellman groups and all that. And the point of all this is that TLS configuration best practices change fairly quickly. And if you're not keeping up with that, then your configuration is going to be out of date, and you're going to have to go manually update your Cipher suites all the time. And SSL Labs has a cool tool called SSL Test that you can use to see how well your SSL server configuration compares to current best practices. Oh, so the creator of SSL Test, Ivan, also wrote this great book about SSL and TLS configuration that I always throw in here. Another problem, so let's assume, okay, you've set up TLS and you have your configuration, you're happy with it. Then you might run into a problem called mixed content blocking. So basically when you visit a page over HTTPS, such as Lenovo.com, your browser does not want to load resources over HTTP after that. Essentially, if you're on an HTTPS site and the URL bar says HTTPS, the user expectation is that they will be secure and they won't be having, they won't have resources such as scripts loaded over plain HTTP. So the browser hard fails and actually says we're not going to load any resources over HTTP if the site's already HTTPS, the top level site that is. So what happens is you switch over to HTTPS, but you have a lot of legacy resources that are HTTP, And those resources just simply get blocked. And so you end up with a site that has, that is over HTTPS, but like style sheets and images and scripts aren't loading. And so your site looks pretty broken. So how many people use HTTPS Everywhere? Okay, a few. So HTTPS Everywhere is a project from EFF that will try to switch requests. So this is a client-side project. Like this is a browser extension. And when you visit a site, it will try to switch requests to HTTPS if we know that that HTTPS is available on that server. So HTTPS Everywhere Chrome has this tool to help you switch over to HTTPS by telling you what resources could be converted. Right, so say that you're New York Times and you're over HTTP, but actually many of your subdomains and many of your third-party domains support HTTPS. Well, you can use HTTPS Everywhere to kind of figure out what those are and manually fix them in your HTML files. W3C is also working on this problem because it's preventing a lot of people from switching over to full HTTPS. So there's now a content security policy directive called upgrade insecure requests. Basically, your server sends back a HTTP response header that says upgrade insecure requests, and the browser will try to fetch things over HTTPS instead of HTTP. So if your content supports HTTPS, but you just don't have the resources or don't have the ability to go into all your HTML files and manually rewrite and add an S to all the links, then you can use this header as a shortcut. And the final problem is that there's just a lot of certificate authorities, perhaps too many. So Peter did a study a few years ago in the Decentralized SSL Observatory and found that there's a lot of intermediates, right?
Yeah, so what we did is we port scanned all of port 443 on the public IPv4 address space, and we downloaded all the certificates that we found there. And we tried to figure out who they'd been issued by and whether browsers would trust them. And although at the time everyone thought that there were about 50 or 60 certificate authorities that would be trusted by any browser, because that's what you saw if you went and looked in Firefox or whatever browser you were using, we discovered that in fact there were thousands of certificate authorities operated by probably hundreds of organizations that could actually issue a certificate for google.com and be trusted by your browser. And the reason no one knew about them all is because they were being cross-signed by other certificate authorities. And there was no central registry of who all these organizations were. But they are all part of the attack surface that's applicable to basically any site on the web.
Yeah. And so this is a real problem. A few months ago, Chrome detected that there were unauthorized certificates issued for Google domains by an intermediate certificate authority, which was issued by CNNIC, sorry. So this is a real problem today, right? And so Let's Encrypt is going to try to solve all of those. And sorry, we're doing an awkward transition here.
All right, so I'm going to talk about two kinds of solutions to these problems that we believe we need to offer. One is a solution for security, and that means turning on HTTPS and making sure that it actually provides the guarantees that it's supposed to provide. And secondly, it needs to also be a solution for usability. It's no good to have really strong ciphers and really strong protocols if the humans who are supposed to use these things cannot succeed in doing so. And so probably the biggest lesson we've learned in computer security in the last decade is that there is no security without usability. The two inherently have to come together or they don't exist at all. So our plan is to offer a new certificate authority called Let's Encrypt. Actually, so as you can tell here, our solution to the problem of there being too many certificate authorities is to provide one more. But we're trying to provide one more and actually do it right this time. So both really strong security guarantees and really great usability properties and automation properties all the way through. Now, on the security front, there is this giant question that we have to answer. If we're intending to offer an automated certificate infrastructure for every website, and someone comes along and asks us, will you give me a certificate for my little website here or for Facebook.com? How do we decide whether the answer is yes or the answer is no? And you can think of this as being like a scene from Monty Python's Quest for the Holy Grail. People come along and say, will you give us a certificate? And we say, yes, actually, but first you must bring us a shrubbery. And then they come along and they bring you a shrubbery and you say, well, that's very nice, but actually we'd like another shrubbery, please. And so the way this happens is actually in an automated protocol called ACME that's being standardized at the IETF. And the shrubberies correspond to challenges that are issued in this protocol. So the CA, or server for the protocol, issues a challenge to your client, which is actually a web server or some other type of server. Perhaps today you can imagine it's an Nginx server. It's a client for this protocol. The server says, bring us a shrubbery, and then your software on your server runs around, tries to provide the shrubbery, pass the challenge, and when those challenges are passed, you get a certificate. The most fundamental challenge we have to solve here is a bootstrapping problem. Given that we don't start off with any cryptography in place, we don't know what keys to use, how do we bootstrap some kind of reliable trust in a web server that claims to control example.com or facebook.com? So the usual answer that certificate authorities have today, at least for bulk issuance of a lot of certificates, is to use this process called domain validation. And typically, that involves sending an email to a purportedly administrative username at that domain name. So admin@example.com, webmaster@example.com, root@example.com. An email will be just sent to that email address. If a link in the email is clicked, then the CA considers that sufficient permission to issue a certificate for that domain name. Some CAs, it's rarer, but some CAs today will also let you post a nonce file that they've given you at a special URL on your HTTP website. And if they find that nonce present, then they will consider that you've passed the request that they made, and they'll start issuing you a certificate to upgrade to HTTPS. So if you're paying attention here, you should realize several things. First of all, of course, with this admin@example.com, every email server on the web needs to reserve a bunch of email addresses and never issue them to their users lest something go horribly wrong. In fact, our collaborator on this project, Alex Haldeman at the University of Michigan, he's just a professor there, managed to get the email address admin@umich.edu. So he now is able to get certificates for any site at his university or domain name at his university. But you need to make sure that doesn't happen. But more fundamentally, there's an issue here, which is these are non-cryptographic authentication methods. And so you're kind of just like taking a punt and hoping that it turns out all right. So what are we going to do? So at launch, we're going to support two things that are essentially variants of domain validation. The simple HTTP one is basically exactly the same as this nonce that was happening with existing CAs. We're also going to support a new type of domain validation called DVSNI. And that basically means posting a bunch of virtual host entries in your web server configuration file for domain names that don't really exist, and serving special prearranged fake certificates for those non-existent domain names. And that proves to us that you not only have some kind of access to that server, maybe file system access, but you actually have kind of root access or whatever permission is required to reconfigure the web server. Later on, we may offer DNS validation and maybe some types of validation on ports other than 443. But for launch, at minimum, we're going to offer these first two. But, as I pointed out before, this is fundamentally scary. We are not using cryptography here. CAs are not using cryptography. What we do when we try to validate a domain name is we send some packets off down the dark corridor of the internet, and we have no idea what monsters may lurk on the network. And then we get a response back saying, yep, I had your nonce file, it looks right. But any compromised router or any compromised DNS server on the network can be used to fool us into thinking that a domain requested and passed one of these challenges when in fact it was an attacker that had done that. So this is not a very reassuring situation to be in. We can do slightly better. So rather than just doing one single dark corridor through the internet, we can at least try to perform this validation from several places on the network. So we make an HTTP request or an DVSNI request from a couple of places. And then in order to compromise us, the monster in the dark corridor would have to be lurking either on multiple places on the network, or they would have to be right near the victim's server. So if they compromise the victim's own router and the last hop before the server, then they can pass the challenge on all of these paths, but otherwise they'll have trouble doing so. This is still not good enough, actually. It's fine to do this some of the time, but for the whole internet, for high-value domains, this would get compromised sometimes. So what we do is we actually ensure that this pure domain validation with no cryptography only happens once for any given domain. And the way we do that is using the same techniques, the SSL observatory that Jan was mentioning before, where we have a data set of all the certificates in existence. We get that both by scanning the internet and also by having around 1 million Firefox clients. People who use HTTPS everywhere can opt into sending us certificates that they see. So we have this big database, both from scans and from decentralized observation. And we look in that database when we're about to issue a certificate, and we say, is there an existing valid certificate for the domain name we're about to issue? So you come to us and you say, I want facebook.com, or I want some obscure bank in New Zealand.com, and we say, oh, well, that domain name has an existing valid certificate that we've seen somewhere on the internet. So we are not going to give you a mere domain validation-based certificate. What we're going to do is demand that you bring us a different type of shrubbery called a proof of possession challenge. You're going to have to prove that you have the private key in the pre-existing certificate. And if you don't, we won't automatically issue you a cert. So that protects us from accidentally allowing a router compromise to turn into a certificate for a high-value website like a bank somewhere or a corporate webmail system. It does mean, if you're paying attention here, that if you got a certificate from someone and then you lost the private key, you're kind of in a bind because we're going to ask you to prove possession of this private key that you've lost. The only way to recover from that is either going to be to wait for that old certificate to expire, or to go to another certificate authority somewhere and buy a certificate from them, and then come back to us again and say, now please bring me a certificate. We'll say, please prove that you possess one of these two different private keys, the one that you lost, or the one in the cert you just paid for, and now you can complete the challenge and proceed with us. But we think that's the necessary protection that we need to offer if we're trying to do this sort of automated authentication for the whole web. And for those of you who are familiar with TOFU, Trust on First Use is one of the algorithmic models for how to do cryptographic bootstrapping. If you use SSH, you're familiar with this model. It basically says the first time you see a key, you trust it. The second time around you see a key, if it's different, you basically get a warning. We're essentially doing the same kind of thing for HTTPS. So the first time you ask to make your domain name HTTPS, we'll just believe you. The second time around, if it's already been HTTPS, we're going to need proof from the old key chained together. So we're pretty confident that this is at least significantly better than what the current CAs are doing, and should hopefully be a model that operates successfully at internet scale. So the next problem we need to solve is the fact that there are so many, as Jan was describing, there are so many things that you need to get right in order to deploy TLS correctly. And basically you need a PhD in computer security, or you need to be sitting around and reading news stories every week to follow the latest optimal configurations to not be vulnerable to Heartbleed or Logjam or Beast or Crime or all these attacks. And we want to not have the problem of everyone needing to know this stuff. So we want to provide a client or an agent that runs on your web server that basically does something correct for you in an automated fashion. And so you can think of this as trying to change the current situation where every web developer on the planet, there are millions of web developers on the planet, and they are supposed to, I think right now, all understand how TLS works in its horrible, gory details. And it's kind of insane to expect every web developer to know about this stuff. We're trying to change that so that we can have basically a small team of people who study HTTPS and TLS configurations, figure out the best ones, and then get those automatically deployed to the millions of web developers who need to use HTTPS. So the plan for the client, and this is the Python client that we're developing at EFF, there will be other clients, is tweak your web server. It could be Apache, Nginx, or something else, and Jan's going to talk more about this later. Tweak the server to pass the challenges that have been given to you. Install the resulting certificate, then tweak all of your Cipher suites and other security options so that you have a really good setup. And then automate the task of renewal so that you don't have the problem. Anyone who's deployed HTTPS will know you deploy it, you go through all the hours of figuring out how to get your certificate. 11 months pass, you've completely forgotten how you did it, and then your certificate expires and your site goes down, and then you're left back at square one again trying to remember what you did to get that certificate. So we're going to try to automate both the renewal process and response to certain kinds of security emergencies. In our ideal world, if the next time there's a Heartbleed type vulnerability, we'll be able to do something for people who've asked us to in comparatively real time to ensure that people are less vulnerable. So what kinds of security automation can we do here? There are easy kinds like tuning the ciphers, turning on OCSP stapling, turning on this cool new feature that the W3C is working on called CSP Upgrade Insecure, which fixes some, though not all, of those mixed content problems Jan was mentioning before. There are medium difficulty tasks where probably most people can have this stuff done for them, but it's a little bit more, there's a little bit more risk of breakage, such as upgrading modern clients from HTTP to HTTPS with a redirect, automating renewal, automating rekeying when you need it. The hardest category are things that probably need to be done for websites, but actually have significant risk of breaking your site. So for these, you'll need to add explicit flags or get some hand-holding from our client as you turn them on. That's like a full rewrite for every type of client, or HSTS. HSTS, by the way, how many people here know about HSTS? That's pretty good. A quarter, maybe a quarter of the room. If you don't turn on HSTS for your website is not secure. There is no such thing as a secure website that doesn't use this thing. It is a necessary mechanism to ensure that when the user first types your domain name in the URL bar, they don't get hijacked straight away and sent to some other phishing site. And it also ensures that your cookies are structurally protected against trivially being hijacked. There are other ways to protect the cookies. There are no other ways to prevent stripping, but basically, if you don't know about HSTS, we're going to need to help you find out about it and find out how to turn it on. And then the hardest, and this is sort of more speculative, would be to actually fix your mixed content inside your HTML pages on the fly or automatically in some way. Obviously, in the most general case, this is impossible because your pages can be full of Turing-complete JavaScript that spit out URLs that may or may not contain an HTTP. But at least for some cases, we should be able to either look through the code you're serving or run a proxy in between your website and the world. The other thing that we might be able to do is this type of HPKP pinning, where you protect yourself against the hundreds of other certificate authorities that you weren't intending to use, but which could be used to issue a certificate to attack you, like the Chinese certificate CNNIC. These kinds of protections are going to require a lot of care for deployment, and in the case of the mixed content protections, it's going to take a lot of work. So this is very much roadmap stuff, but we're going to start with the easiest stuff on this page and work our way up. But fundamentally, even though we're trying to do this right, whether it's our CA or anyone else's CA, these objects are terrifying. Running one is terrifying, the existing ones are terrifying. They're giant machines that can issue certificates for any domain name. In our case, it's trying to issue certificates for any domain name that legitimately comes and asks us. And this thing can go wrong. It's a huge, complicated machine. So we're planning to try and defend our systems in depth. So that one exploit or one compromise can't break the whole thing. But more fundamentally, we have to plan to detect and survive if we get compromised. So one thing we're planning to do is to publish logs of all of the requests we get for certificates and the process that we use to decide whether to issue or not issue and the results. So if you're a security engineer, you can just come and watch what we're doing and make sure that we aren't getting tricked into issuing things we shouldn't be. We're going to publish a full remotely verifiable history of everything we've signed. So you can go and look at the certs that we did issue and confirm that every cert you see is one of those and that they're correct. We're going to publish those via Google's certificate transparency protocol. For protecting against the other CAs, as I mentioned, you can use this HPKP pinning thing. We'll probably have a command line flag to turn that on if you're brave/crazy. Just make sure you don't break your site with it. And conceivably, either because of a compromise like Heartbleed or because of the worst case is our own CAs getting hacked, like an intermediate CA key getting compromised, we're planning to try and support rapid server-initiated reissuance. So if we put up a warning flag saying, hey, within the next short window of time, these certs need to be reissued or these keys need to be changed, there'll be a clear way to signal that to the client, and it can go and poll and say, oh, hang on, I need to rekey my web server, and that happens automatically within 24 hours without your site going offline. So those are the kinds of protections we want to put in place. Happy to take more questions about those later, but a little bit of meta stuff about the project. This began as a merger of a project that EFF was working on with the University of Michigan and a separate project to do much the same thing at Mozilla. It is now housed in its own nonprofit called the Internet Security Research Group, or ISRG. ISRG is a membership-based organization funded by its sponsor members. So if you guys work for companies that think this is valuable work, please consider coming and joining ISRG and sponsoring what we're doing here. The major sponsors at the moment are EFF, Mozilla, Cisco, and Akamai. We have other sponsors, IdenTrust, Automatic, missing from this list of the American Library Association, and some other new sponsors coming on board. And in terms of the work that's being done, the breakdown is roughly operation of the CA's servers is largely ISRG stuff and Mozilla stuff. The code that runs on the server that demands shrubberies and decides whether to issue or not is being written by Mozilla and EFF. The Python client code that we're talking about today is being written by EFF and University of Michigan, and everyone's pulling their weight on the policy, legal, and bureaucratic tasks required to become a CA, which are quite considerable. The current schedule, we have actually issued our first certificate. There will be a beta program in mid-October, and that will correspond with our certificate authority being cross-signed by an existing certificate authority. So right now our certificates are not valid in a browser, but when that cross-signing event happens, they will become valid in all of your browsers. Interestingly, you might think you need to be added to the browser's root list to become valid, but that's not actually the relevant step. The relevant step is the cross-sign. We will also be added to the browsers from October onwards, I think. And then sometime around the week of the 16th of November, we will turn on Let's Encrypt as a server that everyone can use. And up to a certain rate limit of certs that we'll hopefully be raising continuously, you'll be able to come and get a cert for any domain name.
Okay, cool. So we have a few minutes left. I'm just going to briefly talk about Let's Encrypt on Nginx, because that's where we're at the Nginx conference. So this is getting a little deep in the weeds of Let's Encrypt development, but basically there's a thing called a Let's Encrypt plugin. We don't have to merge plugins into our main code. Like any of you guys can write plugins. And the plugins are usually custom implementations of one of these three interfaces, or some combination thereof. So an authenticator proves to the CA that you own some domain, An installer does the work of actually deploying the cert and configuring your SSL correctly. And the displayer replaces our really ugly and curses UI if you want to do that. And so this is all done in Python. You can load them through setup tools. So currently we're shipping with an authenticator and installer plugin for Apache and Nginx. So I'm just going to talk about what the Nginx plugin does because I wrote it. And so the first thing we do is we go through your Nginx config files. You can specify the root directory if it's not in etc Nginx. And we parse this into Python data structures. So I say recursively because you can say include configuration files in your Nginx main configuration. So we'll go through all of the included files. So we parse that into this sort of tree that we can now manipulate. So the authenticator does the work of doing authentication. So as Peter said, one of the ways to prove that you own a domain is to be able to modify the server config files to set up a new virtual host. That's what the DVSNI protocol does. So when we do the DVSNI proof, we actually have to mangle your config files a little bit to add a new server block that listens on a randomized subdomain. So we do that, and then when we're done, we revert all that configuration change. And hopefully that was successful, so we'll give you the CA signed certificate now. So now we have the certificate, we want to install it. The plugin has some complicated logic to find the server block that best matches a provided host name. The user experience is that the user says, I want to get a certificate for example.com. And we look through your config file and we say, what server block looks like it best matches example.com. Nginx has a native way of doing this, and we kind of mimic that. So when we find that block, we say, okay, now that's the block we want to support SSL in. So we'll have it listen on port 443 by default and add SSL to the listen directive. And then we'll add these 3 lines at the bottom that say SSL certificate, your certificate, SSL key, your key, and include SSLoptions.conf. So SSLoptions.conf is a file that we give you that has the current best practices for SSL. So the Cipher suites and all that. And you most likely you'll have to tweak that depending on your server needs. But basically, once that's done, we just dump the whole thing back into your config file and reload Nginx, and you should be good to go. So what does this look like in practice? Hopefully you can see this. So I have this server that's running Nginx, and I go to HTTPS, my subdomain, and it says not available. I'm sad. So I'm SSH'd in. This is just default Nginx on Ubuntu with TLS support, and that's what my config file looks like. I think it's just the default for Nginx. So I've installed Let's Encrypt through my package manager, or I've git cloned it or something, and I say Let's Encrypt run. And I select Nginx because that's what I'm using. This is the ugly curses UI. If you don't want to use that, there's pure command line options you can do. So I select the domain or domains that I want to set up SSL for.
And it tried to guess which ones you had available, right?
Yeah, so that's when it looked through my config files and found which server names I had defined. And now I go back and I look at my config file, which I'm failing to find, site's enabled. And so I'll pause it right there. Oops. Maybe I'll go back a little bit. So now you can see Let's Encrypt has modified my server file to add these SSL blocks. At the time we did this, we still don't have a cross signature, so it'll just show a connection error, not private error, because we don't have a valid signature from a CA yet. But in the future, that'll just be SSL, and you'll get the nice green lock icon and all that. And that's it. So we have to support other authentication methods. Right now, there's only DVSNI. Eventually, we want to do the config enhancements that Peter talked about, such as setting up HSTS and setting up redirects. Config file parsing is actually really fragile right now. I'd love to hear if there's better ways of doing this, because as Nginx adds new features, our parser will probably break a lot.
In fact, are we looking for people to help with that?
Yeah, so I'm actually going to get that now. So you can contribute on GitHub, and also we are hiring for
we would definitely love,
maintain.
at minimum, to have a contractor or a volunteer or contractor to help with the Nginx port in particular. We have it going for a lot of cases, but we want to make sure that it works for every Nginx conf we're likely to encounter in the wild by the time we're live in November.
Yeah, so I've run the parser on a pretty complicated production Nginx conf that a certain large internet site uses, and it didn't break, but I'm sure there's lots of cases that will break it. So we need help with that. Cool, that's how you can get in touch with us. Sorry we're a little over time. let'sencrypt.org. I'm Jan, this is Peter. That's it, thanks.